All right, almost there. Get that going. All right, getting there, everybody. Last few minute things. Had to tweak my setup here a little bit for build streaming versus coding streaming, which is what I'm usually doing nowadays. Can you hear me okay? Hear me okay? Let's see. Getting there, getting there. Okay, let's see. Getting a few more things pulled up. See if we get anybody else joining me while I grab tools and things here. Do-ba-do-do-do-do. Got one person joined so far. All right. Solder. All right, here we go. Boop. Where are we at? All right. So, a little bit of a different stream today. Moved my usual nice webcam to point down at my build surface here. Hopefully that's not going to screw things up too much here. I do have also my USB microscope up. That's the thing you see illuminating bubble wrapped PCBs. Just pulling out the rest of my tools so I can get started here on getting this going. So bear with me. And we'll see if I get interrupted by family returning here later today. But we're going to try it. I couldn't resist. So here we go. Gonna need these. Yes. Should mostly get us there. So the real question today is going to be, is Pete going to melt the wire to his headset? That's really the main thing that we're going to have to see if that's going to happen today or not while I'm doing this. I don't usually do this setup. We moved to Denver a little while ago, Denver suburbs. And so my desk setup is totally different than the last time I did a build stream where I actually built stuff and I sort of quickly threw things together. So we've got two wires that might bite the dust here today. We've got my lovely headphone wire here that's going to be like right in the way. And then this one, less likely to bite the dust here, is the cable to my little USB microscope. One of the two, I think, has a good chance of me screwing up. And if you hear me screaming and suddenly my audio isn't working, it's probably because my headset took the brunt of it here. So I'm going to work on getting set up. Where did I put that screwdriver? Here we go. I'll show you all here what I'm building here in a minute once I've got a little bit more of my desk set away. Sadly, the lovely high-res webcam that usually gives you my bearded visage is now build cam, so you get my crappy laptop webcam off to the corner here, so you don't get to see me as well while I'm building. What are we going to do? Sacrifices must be made. So in just a second, once I have all my tools squared away, I will unwrap these PCBs. We'll see what we're working on here today. Since I did my first Topreviung build, which I'll grab to show you here. First build went fairly well. I'll throw this under here. Here's the build. Couple things were problematic that I had to redo. My controller area was like butting up against my plate. I had to put some Kapton tape there. That was lame. The USB plug kept hitting on the plate assembly here, and so like that was kind of lame. And I went to go do the case design for this, and that was problematic. So a lot of the same stuff here on the back side has not changed in terms of like the major component structures, whatever. Mostly sort of like round 2 cleanup here, and so we're going to be building one of these today. Hopefully we'll get pretty far on the assembly process, but that's the plan. I do have a case this time. Shove this over here. I just used JLC. It's a pretty basic tray case here. It's got a little warp. Not too bad. A little bit of warp going on here in terms of the case itself. Hopefully we'll get to the point we'll get the solder nuts on. It's a pretty basic assembly on the case. There's solder nuts soldered to the bottom of the PCB that are threaded. I'll have some M3 screws going through the bottom of the case and into that. When we get there's a little flex, a little warp. Hopefully once it's secured to the PCB, it'll flatten it out. So hopefully we'll get to the point that we're gonna manage to set that in the case here. But that's what we're doing today. So there's some decently small soldering. When we get to it, I will pull up my screen here. Oh, that's some awesome feedback. I could have sworn I got rid of all that annoyingness here. Get rid of that, hopefully. So that's what we're going to do today. So these are plates. We're going to look at those here in a bit. Here are the PCBs. We're going to get those unwrapped, start looking at what we're talking about here, and get going on things. So if you want to let me know how things are going, what you're up to today, if you can hear me okay, all those things. We're going to get these PCBs unwrapped. 4-layer PCBs from JLC are more expensive. So in the interest of cost savings, we've got green here for us today. It just is what it is. Whenever I do more expensive prototypes of things, I tend to cut costs where I can. So let's move this out of the way for now. Here's what we're working on. We're going to get this opened. I've got my ridiculously too large pocket knife, which is threatening to actually take out my audio wire before I even get to the soldering. So we're going to see what we can do to not have to ditch this stream because Pete has killed his audio wire. But we will get this. I both love and despise the JLC bubble wrap. See if I can get this open without slashing myself. Yeah, thanks for joining, Pixel. I don't know if I've seen you on previous streams, but thanks for joining me here. We're going to get this started as soon as I get past the bubble wrap. You know, first level boss here is the stupid JLC bubble wrap. Try and do this without scratching this top PCB. We're almost there, folks. I won't be doing as much typing today, so I won't do my usual, like, what I'm using while I'm streaming, because mostly what I'm using is the Pine Sol and a bunch of tools, and the world's cheapest multimeter for checking my work as I'm going here. Okay. There we go. That's what we're talking about. As I mentioned, 6-layer PCB, not that you can see it really while I'm working here. Put the spares to the side here. All right, this is what we're working with. Can put away the knife for now until we unwrap plates. Let's take a look here. So this is what we're talking about. We're going to be assembling the backside for the most part. We've got some an op amp and support circuitry. We've got our couple analog muxes, which are used for selecting the line when we're doing reads. Oh, hey, welcome, Reeve. And so we're going to do that. We're going to do the reset button, and we'll assemble the controller. I did some tweaks to the controller area here for some lower profile build for the Zhao. And then we will do our best to test this without the full assembly, and then I don't know if I'll get to doing an assembly with all the springs and domes and all that with a plate. We'll see how it goes. We may just get soldering done so at least folks can see how that build goes. So most of my work here is going to be done on this USB microscope, and we'll switch over views to my screen where you can see the work here. But fundamentally, we're going to get that going. I got to get my soldering iron up, doing a fair amount of drag soldering here, and so my setup here is going to be with chisel / knife. I never remember the difference. Chisel, knife tip, I can never remember. But that we're going to use that for the drag soldering here. I have the pine saw, the original, the V1. I have the fine tip set that you can get to go with them. I find that works well for what I'm doing. Got my roll of solder. Got to grab my components here in a second. We're going to get the soldering iron warming up. As with all things, we're going to use a decent amount of flux to keep things flowing. I've got some solder wick should the need arise here. I'm going to get my iron heating up, grab some components, and get to some tiny soldering. Where'd I put my box of stuff? All right. All right, box of components. Where's my power for my iron? All right, seriously though, I do need to figure out how I'm gonna not fry the audio cable on my headset. I'm gonna do a little bit of like hover it above stuff. See how that works. I'm gonna go for the most awkward soldering setup ever. Just to add to the fun that is today. All right, so we've got my solder, got my wick, got my tweezers. Those will come in handy. Hey, thanks for joining, Sam. Get to see me flail about doing some soldering. Let me know if you can hear okay. I got the box of stuff here. We're going to start here. Let's do this. Let's switch views here, everybody. A close-up action here of everything going on. We're going to be soldering this area first, right? So we've got a few things going on. We've got 2 different AMUXs we're going to do some drag soldering on, and then we're going to get all this area. We've got the op amp here, as well as the support components, our resistors that are tuning the analog bits. And once we get all those squared away and good, we'll work on the controller area here. We've got some pogo pins we're putting in. We've got some sockets on the sides, but we're going to start with these op amps. So it's really basically just 2 AMUXs. We're going to get 2 AMUXs. They both have a decoupling cap right next to them. So that's our first order of business here. Looking for those in my box of stuff here. There's one of them. I had to place another DigiKey order for the rest of the stuff for this. There's the other one. All right. So, all right. Anybody on stream done this fun small soldering stuff before? Am I going to embarrass myself with experienced soldering folks, or do I get to pretend I know what I'm doing and have folks ooh and awe at my flailing about here? All right. So that's what we're talking about here. Get this static bag out of the way. Iron's up to temperature. Get this going here. All right. So anytime we're doing this sort of like small SMD stuff, our general strategy here for anybody who hasn't done stuff this small, we're generally going to be doing the following. We're going to be tinning one pad, reflow it while we get the component in place. Then once we know that the component is like properly positioned, then we will tack down one more leg and make sure it's secure before we drag solder the rest. Yeah, so that's the plan here. So we've got our AMUX. We got it here. The first order of business, we got to make sure we got the one pin lined up here. Footprint here is pretty nicely indicating that here with the little triangle here. Older versions of KiCad had like a longer line sometimes. Sometimes you'll see a longer line as a like a pin 1 indicator. In this case, newer KiCad versions, I think it was 8, maybe they updated their footprints and moved to this like arrow indicator. So you got a pretty clear indicator here. Here's your pin 1. Looking at our component, pretty straightforward. Most components have pretty clear indicators. There's our pin 1 here. So we know we've got our AMUX. We know our pin 1. We're going to be getting this bad boy soldered right here. So here's our first order of business. We're going to pre-tin our tip, make sure our tip's good. We don't need the flux yet, but we will use it when we're doing our drag solder process here. But we don't need it just yet. So we're going to tin our iron. Ooh, that's the thing I didn't do. Whenever you're using a chisel tip like this, please ignore how embarrassingly gross this solder iron tip is. They have like an orientation. When you just use like a normal cone tip, it doesn't matter. In this case, I didn't pay attention and I put it sort of backwards for how I usually work. So I need to carefully, since it's hot, unscrew, attempt to rotate without burning myself. This might be the first moment of fun for our stream here. And then fix it again so that I have my tip oriented the right orientation for how I want to work here. And so I'm going to use my ESD tweezers to spin this so that I don't burn myself. There we go. All right. All right, here we go. All right, getting the iron back up to temperature. We'll clean up the tip a little bit, and we'll work on getting this tack down. We'll see if I had too much coffee before doing small soldering. One tip of advice, don't drink the iced coffee before you do small soldering stuff. I'm not following my own advice here because I had a late night building a silly kids fall festival like carnival game. So I'm tired, so I'm drinking the coffee anyway, so we'll see how shaky my hand is. And we'll go. Okay, so we're going to get some nice solder on our tip. Make sure it's nice and clean. Come on, up to temperature. Make sure the iron is actually heating. Yeah, welcome. We're going to do some Topre building. So we're getting some AMUXs down. We're going to get some op amps down, get all of our components in place. Hopefully by the end of the stream, we'll get to the point where we are testing calibration and all of our sensing, and it's all good. But first order of business, we're going to clean up the iron, get it nice and ready to go. Let's see. Looking embarrassing, but still better in terms of the tip. At least the tip itself is not horrible. So here we go. First order of business, we're going to pre-tin this, and I'm actually going to fix my scope a little bit. Too much glare. My scope has a built-in like light on it, which is sometimes a blessing and sometimes a curse in terms of what it does for when I'm looking at it, because sometimes it leads to like a lot of glare, but sometimes it's okay. So here we go. We're going to tin our first pad, and then we're going to tack down our mux. Come on, heat. Now it just so happens that our first pin is a ground pin, so it's going to take a little bit more. So we've got it pre-tinned. Next order of business is we're going to reflow this while we put our AMUX in place, and we're going to make sure that we have all our pins all lined up before we tack anything else down. That's the key thing with any of this small soldering, is only one pad to start with. The second you have a second pad, your problems multiply if things are not in place. So we're going to be checking both sides. We don't want either side like too far over because it'll make it harder. And we for sure don't want it twisted because that's going to just suck. So here we go. We're going to try and get this held in place, lined up properly on both sides. And we're going to reflow just this one pad here. Get it to flow and set. Give it a second to set. And then we'll release, and we're going to check everything. We're going to quadruple check it, because the second you tack that second pad, you're sort of committed to your alignment here. And so if we take a look, try and shift it a little bit to get it out of the glare here, we're looking good. Both sides are like totally lined up. Neither of the legs is too far, one side or another. So here, get this. This microscope, this was like a gift from my brother. It was like a kid's cheapo USB microscope. and it came with like a sample slide pack of like, this is onion skin, and this is like toenail fungus or whatever the stuff was. And it was literally like, it couldn't have been an expensive microphone, but it was very nice when my brother sent it to the girls. I since pilfered it because the girls looked through it one time, like, oh, look, onion skin, and then they never used the microscope again. But it's absolutely perfect for these sorts of builds. Now, I mean, like something fancy with like, a binocular view, so you get 3D, like, depth is challenging, whatever. But like you can find these like USB microscopes for super cheap, and it just is so much easier for normal soldering. For tiny stuff like this or USB ports, anything like that, it's for sure fun. All right, so we're all lined up. So here's what I'm going to do. I'm going to tack the other corner on the side I was just working on to secure this in place, and then I'm going to drag solder the other side as a way to have the one side secured, and the other side I can then work on soldering and getting all squared away. So we're going to get this corner right here, and we're going to be very careful in particular not to twist it as we go. And that's junk. I've got to clean my tip here, and I'm going to secure with my tweezers if I can find them, just to make sure it doesn't shift it when I do this. And we're going to try and get this to flow and get my pad. Okay, now, yep. Didn't actually catch the pad. I didn't get enough fresh solder. If I need to, I can also add a little flux at this point. But we really want to just get this foot, this, and secured. That should have done it. So we can give a very gentle tap with our tweezers just to make sure it's not moving anywhere. And then again, we're going to double check our alignment. These legs are all aligned the way we want them to. It's looking good. So we're going to flip this around, and I'm going to soak it in a decent amount of flux, and we're going to drag solder that other side. So we've spun our PCB around. You can see there's some flux residue just because I have rosin core flux here. Soaker SSOP. This is TSSOP 18, I think. 16. It's TSSOP 16 if I remember correctly. Yeah. Here, I can look at the bag here. Yeah, it's TSSOP, 16 pin TSSOP. And so this here, if you just joined, is the AMUX, the analog mux. This is the thing that uses an enable and then 3 select lines to basically connect one of our sense lines to our op amp. So when we're sensing a certain position, we're going to strobe. The output, that we're sampling, the AMUX is picking which of those lines that connect to our op amp, which goes into our ADC pin on our controller. Yep. And if any of that's gobbledygook, I had a design where I did design for this stream that I put up on YouTube. I can find a link, I'll send it later. But here's what we're going to do. We're going to get a little flux on here. Now that it's secured, we're just going to be careful because we still don't want to rip the pads. There's just 2 pads securing this right now. So we're going to be very careful with our flux. Get it decently on there. This is why I like the knife or the chisel tip for this, because we're going to put a little solder on our iron, and then it's going to basically act as a little reservoir of solder that's going to pull onto these pins if I do this well. This is where this is either going to go awesome and you're all going to be wildly impressed with my soldering skills, or it's going to be an absolute mess. And we're going to do a bunch of cleanup. I don't know which it's going to be. We're about to find out, but it's going to be one of those things. Nothing feels better than nailing a drag solder the first time you're running it, and it's just boom, done, soldered. Whether that happens on stream when I'm distracted and I'm caffeinated, we'll see. So we're going to get a decent amount on our iron. We're going to let it come onto our pins, and we're going to drag and massively blob it up because I did way too much solder. As you can see, the tip to drag soldering, not too much solder. Had I followed that advice, we'd have a much better situation here. Way too much solder here. So we're going to reheat, and we're going to drag, and we're going to get some of it cleaned up. But as you can see, I've got way too much solder here. I needed about half of that amount of solder for this to go well. So we can still do a little bit of drag, but you can see because it's all flowing, even with my decent amount of flux, I got a giant blob here. It's just too much solder. I can try and pull it back the other way. And sometimes that'll work, but as you can see, it just dragged my blob the other direction because I just have too much solder here. Now, our friend, I mentioned I would be using our friend here today, solder wick. We're going to use it because I find when you're doing any of this sort of work that the solder sucker, I don't find it to be as reliable. When I'm just trying to like pull a little bit off that I've added too much when I'm drag soldering. Yeah, and honestly, it pre-tinned that cap pad for me. That's fine. I was going to have to do that anyways, right? That's not a big deal. Yeah, you can see nicely pre-tinned for me. Bonus. But we don't need all of this on here. So we've got a decent amount of flux already on here. So we're going to attempt to just pull off some of our solder with our wick. Not too much. Yeah, not too much. Just a little bit. Now I'm going to just reapply a little bit more flux here because I've burned away some of it. And honestly, with this stuff, too much flux is rarely a problem. And so, yeah. And so now we're going to flow this again, hopefully with the right amount of solder on this, and see how we do in terms of getting all of these pads soldered. And I think I have now got a different problem, which is just a little bit too little solder in one or two spots here. So we're going to not overfill our iron. We're going to give it the tiniest a bit. And then see how we do in terms of giving this just a little. And you can see the flux here is really doing its job. I'm feeling happier about this now. If we look here now, obviously the flux is all over the place here. But we got a nice flow across all of our legs. They all look like they're soldered. I'm going to do the other side. Yeah, pretty much. I got that wick on there, and when I did so, it's a little tricky to time it, right? But I pulled a little bit too much off of my joints, and so I added just a tiny touch more to make sure I had enough solder for all the pins on that side. Yep. Yeah, exactly right. So the wick, it's a delicate balance here, right? Like I'd rather take a little bit too much away with the wick and then add a tiny bit more than leave it. So I left my wick on maybe a scotch longer than I needed to. But that side's good enough. We're going to check it all here in a minute. But we're going to get to the other side here where we've still got a decent amount of flux, and having, learned my lesson that I learn every time I do this. I will not overdo it on the solder this time. Again, add a little bit more fresh flux here. We're going to clean all this up with some IPA here in a minute. But we're going to get this other side done. And again, I already had two of these pins done. So we're going to get just a tiny bit of solder, not too much, on my iron. And I'm going to inevitably do too much again. But we're going to get this to hit. We're going to pull it out a little bit. There we go. That side was way better. You can see when I finished, I had the tiniest bit of too much right on the end. And a trick you can do here when you're doing this is you sort of get your iron against it and drag away. Once you're done sort of dragging along in parallel with them. And if you have enough flux, it'll tend to be enough that'll do its thing. And we're here. Flux clean and cut it. Yeah, that's coming. I got to go grab the IPA so we can get this going. Here's the fun part. My setup, as fancy as this looks, all levels of jank. So there's no nice toothbrush. We're grabbing some Q-tips. We're going to leave some cotton fuzz on this when we're done for a little bit of sort of nice, personality here. So grabbing the IPA, because of course I'm streaming last minute. Grabbing the IPA, we'll do a little flux cleanup. Then we're going to check with our meter and make sure we're squared away here. Okay. Okay. I have my super advanced IPA and Q-tip cleaning technique. For anybody that really wants to do this right, get yourself a toothbrush. Not one that you've used, please. No, we don't need to leave any plaque on your PCBs. But get yourself a toothbrush. Stiff, stiff brush, toothbrush, and use that. But we're going to do this. So IPA does not technically make flux go away. It makes it so that it can be absorbed. So if all I did was spread this around, I would end up with a bunch of like flux residue spread all over the board. So I am getting one end of my Q-tip with my IPA, and I am well dousing it in IPA, and then I'm using my other dry end to try and soak up a bunch of that IPA flux mix to get rid of our flux residue. Not a perfect technique, admittedly, but we're going to clean it up. Now, this should air dry here in a minute. I'll get the canned air if I need to. But as this starts to air dry, yeah, I know, right? Every time I'm thinking electric toothbrush. Now, there's an idea. Maybe I could just grab a spare head for our electric toothbrush and just use that every time I'm working. I'm sure my wife would love that. So we've still got a little too much moisture here. I could grab the canned air and just blow at it, but I'll wipe a little bit more away. Get it dried out. You can see a few things happen. One, cheap solder mask. I've scraped the solder mask a little bit on this, so I do need to be a little bit mindful of that. Our thing is still just drowned. I did too much IPA. But we can see that the joints are looking pretty good. I'm fairly happy with my joints here. Yeah, indeed. And so we'll check a few things with my multimeter, just to spot check things, but it's looking pretty good. I'm probably going to just move on to the other mix, analog mux, and then I'll add the decoupling capacitors sort of in one go, since I got a few of them all the same value, right? So anytime I'm doing this small pitch stuff, I'm usually checking two things. I can visually inspect this, and it's looking pretty darn good, but you can sometimes have shorts between adjacent pins. That's the most common problem when you're doing drag soldering like this, right? And so what I'll typically do is I'll do like a run where I am checking pin against adjacent pin to make sure that they are not shorting to the adjacent pin. Now, in some cases they will, right? Like if multiple pins are grounded, I got that at the end here, but like I shouldn't have. So I need to double check this. I'm almost positive these are two just grounded pins. I'm getting a beep there. And those two. So the two spots I've got, like my meter and continuity is beeping, is these two pins and these two pins. So I'm going to pull up the schematic, quadruple check things. Yeah, it goes fairly quickly once you get sort of the feel for it. Let's see. We're going to pull up KiCad here. We'll pull up the schematic for this one. Just to double check things. Topreviung. Looking at the PCB here. I'm going to do view, flipboard view, because we're looking at the back here. We're going to do dimmed, so I can just see the back layer here. And we can see that my bottom two pins are, in fact, they're just connected to their ground, and my top two pins are just connected to their ground. So, this is cool in the gang. I don't have any other adjacent pins shorted. I'm happy. Now, one thing that I had when I was assembling the previous prototypes on this is I had some flux residue that was affecting the analog sensing. And so I may need to do a second pass of like major IPA cleaning to avoid that. It was a level of like the flux residue was just conductive enough that it was pulling some pins to ground. And not enough that it, like in continuity mode, my multimeter would check it up, but it was enough for the very small spike of voltage from the analog sensing to get drained early, and it was screwing up my analog sensing. So I might need to do like another pass of some serious like IPA and canned air cleanup here. But to start with, we're happy with this. No shorts, no major problems. We're going to do the IPA cleanup if we need to later. But here we go. Here's our next mux we're going to do. Just going to wipe that off with my finger. Who needs anything nicer than that? Get another drink, and we'll work on the second one here. We can see that this second one is flipped. You can see that my one pin is now in the bottom right corner, so I need to be mindful of that when I go to assemble my next one here to make sure I don't just sort of assume the orientation. But we're going to grab one more of these. Grab my scissors. Nope, don't have my scissors with me. Where did those go? Grab my flush cutters and cut off just the one that I need. I grabbed spares for other builds here, but there's my component in its nice tape. What are you drinking? Cheap cold brew coffee. Nothing fancy. I made myself a nice pour over here this morning, but afternoon was I was going for efficiency, not for flavor, and so chameleon cold brew, milk on ice. Boring. Definitely boring. All right. So next one, same trick here. It doesn't really matter which pin we tack down first. I'm going to do the top left again, just because that's my sort of comfort zone here. But here's our component. I flipped it over. We're going to flip it back over here. And then again, we're going to double check our orientation. We're going to make sure our pin 1 is in fact oriented, matching the silk here. So here we go again. Okay, so same thing here. We're going to tack down one, double check orientation, tap down a second one, and then get to the drag soldering. So we'll move our component just out of the way while we're getting our first bit of solder in. Make sure our iron didn't go to sleep. That's good. So clean up my iron again since it's been sitting for a bit. Get our first pad done. Now, this will go a little bit easier because my pad isn't a ground pad, so it'll heat a little more easily. Come on, get some solder on there. There we go. Grab our tweezers. Get this in place. And again, even before reflowing, I want to make sure that things are good. What I usually do here is to make sure nothing's moving, I'm sort of bracing the bottoms of my hands, my pinky sort of like palm area, against the PCB to keep things steady. And so I'm going to get this in place, make sure the orientation is good. It's not too far offset one way or another. We'll reflow here. Now it shifted a bit. I felt it shift right as I was finishing, and you can see that I'm close, but I'm just a little bit north of where I want to be. I don't love that, and so I'm going to reflow one more time and just try and get this to be a little bit better positioned. You could get away with this positioning. Oh, look, it didn't even tack down. It's like, no, you're going to want to fix it. So yeah, that I am happier with. So we can see when we shift this a little bit, it's still the tiniest bit north, but I don't want to rip a pad. It's actually really loose. It's barely on there. So I'm going to get a little bit more solder on my iron and reflow that last. Actually, I'm probably going to just tack down another leg. This is good enough. And so we're going to shift this over here, and we're going to just barely get this leg here done. Oh yeah, see, it even popped loose. It's not even there. So here's what we're gonna do. We're gonna add some flux, because part of the problem is I've already reflowed this spot twice. Tiny bit of flux. Let's actually get that in place before we continue. So, lined up decently well. And part of my problem is I just don't have, I'm just kind of just barely enough solder on that one tinned pad. And we can see now I went the other way a little bit. It's just the tiniest bit off south now on that side. So there's still enough flux. We can fix it. Yeah, I can do even more flux if I need to. I think that did it. Yeah, see now my legs are all like perfectly centered in those pads on this right side. And I'm going to double check my left side. They're all looking good. Taper gum. You know, some people, I've heard about people doing that. To me, like, I always feel like I'm going to fiddle with that so much more and then have one more thing to try and like figure out how I'm going to remove it and pull it out of where it was, that I haven't ever tried that. Usually it takes me like one, maybe two repositionings, and then I get it where I want it to be. And then I'm ready to go. So I haven't done that. With it this small, if I'm taping anything down, I'm so worried that like any small shift in tape, and now I'm like fighting the tape, right? And so, all right. Come on, get a little bit of solder on there. Yes. All right. So now again, hey, welcome. You made it. So we're just getting the second analog mux tacked down before we do the drag soldering. Looking totally good on that right side. Totally good on the left side. Yeah, exactly. It's just like one more step for me to like have to spend time on mucking about with. When this technique, although a little fiddly, is like good enough and gets me there, you know? All right, so again, same thing. We're gonna do a decent amount of flux. We've got two pads tacked down on my what is now my right side. So we're gonna, get a decent amount of flux there, not too much solder on my iron. And we're gonna get this other side done. So make sure I'm positioned in camera there. Get just like a tiny bit on my iron. And now we're gonna do it. So we're almost there. We have the tiniest bit too much. You can see I've got a bridge on these top two pins here. So I'm going to do that usual technique where I'm going to heat and pull out. Boom, there we go. Now it does look like, yeah, no, those are all good. Those are all good. So yeah, it's kind of fun. You could see it pull just that tiny bit, right? From the surface tension of the solder, for sure. Yeah, I was noticed that too. Okay, so that drag solder went swimmingly well. I had the tiniest bit of extra, was able to clean it up. I am at about 560 Fahrenheit for my iron. So now we can spin this around. We're going to drag the other side. Now that that side's all squared away, that was a nice and smooth one there. So we'll add a little flux to this side, then we'll clean up. Where'd we go? Where'd we go? There we go. Same thing. We're going to add just a little bit of solder to our iron, and then we will drag. See, that was even too much. I could tell I got too much on my iron. Let's see how that does. Maybe too much. Okay, get the rest off my iron, clean it up. And then you can see I got a bridge here. The top half looks good. So we're going to try and just reflow and pull. You can see it's just a little too much. I can't pull it off. Yep. Yep. Just a little too much. So again, clean it up with the wick just a tiny bit. Hopefully not too much here. Plenty of flux, so my wick's going to do its thing pretty easily here. Even just that, you can just a tiny bit off, and we'll see if I can reflow what's here. Otherwise, we will add now back in a little bit of, yeah, you can see just enough. Yeah, that did it. So, so I had enough excess solder on those other pins that when I do one more drag after the wick, I was able to bring a little bit of solder over to these few middle pins that I had cleaned up here. And I want to look. I can't tell if that's flux or solder. It looks like I may have a short right here still. So before I do any cleanup, I'm just going to check those two pins and see if I've got a short there, to see if I need to clean that up with the iron before I clean here. So you can see it looks like there might be a little solder bridge there, but it might just be the reflection on the flux. So, yep. Ooh, maybe not. Yep. Yeah. Yep. Paste. I've never done the paste thing. No. I would love to try it at some point. The what I'm using right now is a Kester. It's the SN6337 mix is the wire I'm using. And so I did get a little short right here, which you can see. And so I'm going to add a little bit more flux again. I think I don't need to like do the wick trick. I think I can just reflow it and pull it out and it'll be okay. And so we're going to try that again. Yes, that did it. That did it. So when I was inspecting visually, I just saw this tiny hint of a reflection between those two pins. Right? These two pins right here. And so checking with a multimeter, confirmed it. And then just a little bit more flux, make sure it'll flow well. In this case, I did that trick where you sort of drag away along the pin, perpendicular to the pins, and I'll pull it off as you go and to the pad and then away. And so I bet we should be good now in terms of that. Yep. Yep. No more short. So that did it. So same thing, we can clean up our flux here with my lovely Q-tip trick. I keep popping my headphones off, see if the family is returned, and they're going to interrupt the stream here, and I'm going to have to pop off, or how we're doing, but we're doing okay here. So same thing, we're going to drown it in IPA and then clean up with the other end of my thing. And once you clean it up, we can see for sure that these joints are all looking really nice and curved the way they should be. No signs of like cold joints or, I used plenty of flux, so there was no sort of like little tips points from when I pull it away. That's looking really good in terms of the soldering on this one. So we're going to get our op amp in place. That's right over here. We're going to do that next. And then we're going to put all of our support passives on. So the decoupling caps and the resistors and things like that. So that's decently cleaned up. Not great. Again, we might do another passive cleanup at the end here. But we're going to shift over here. This one's going to be pretty straightforward. We're we're going to be doing the op amp is this U3 that we're going to be putting in place. And then we've got, decoupling cap, another cap here for the analog line, and a couple of resistors that we're going to do here. Boop. Fingers are doing the dirty work here. Let's find that component out of my bag here. Digging. Somewhere in this box is the thing I need. There's my op amp. So the op amps I'm using on this one, there's a few different options, for op amps. In particular, basically I took the same op amp component that is used on a lot of the EC designs, and there's a variant of it that has a shutdown pin. And so this is basically the same op amp used on both those designs, but with a shutdown pin, which I'm using because when I build this as a wireless build, the op amp tends to consume a decent amount of power. And so when we go into like a deep sleep, we want to power off the op amp, boop, this bad boy, so that it is not draining a lot of power from your battery when we're not actually scanning our analog stuff for the Topre sensing. So we're going to pull this open. Now, in theory, sometimes I'll switch irons at this point because I'm done doing all of the sort of major drag soldering. But in the interest of efficiency, I'm going to stick with this same tip that I was using, and we're just going to make it work here. Would it sit there drawing current? Yes, yeah, exactly right. And so the op amp has a decent what's called quiescent current, which is a term I never knew before getting into PCB design and electronics. But quiescent current is current that's just like always passively there for the functioning of the thing. This thing is turned over, which is why I'm not seeing the markings on it. There we go. And so there's our component. This slightly longer line is indicating which side has the 1 pin. So we're going to spin this around. We can see I didn't do a great job here with the PCB design, but we can see our little tiny arrow here, which is pointing to our 1 pin for our U3. And so we're going to be tacking this down like this is the plan. So I'm going to spin my PCB just so that I can access the one side of pins easily, sort of with my left hand here. And we're going to be soldering this bad boy right here. Double check my 1 pin. That's my little triangle right there. Cool in the gang. That's where we're headed with it. So same trick, but a little simpler since I'm not drag soldering this. I'm going to tack down just the 1 pin, make sure my alignment's good, and then go from there. All right, to clean that up, we're going to get this out of the way. Tin 1 pad. Grab our tweezers again. Get it in place. Now, it's sometimes a little tricky. The one thing that's always funny is when you go to reposition, you've got this little like mound of solder. So the 1 pin is always raised when you go to start here. And so as soon as you start reflowing, you're like holding in place, but you're also waiting to sort of push it down as you go. And sometimes what I'll do to make sure... yeah. I don't know the pitch on the op amp, but you can definitely see that it is not as small. And so sometimes what I'll do once I've soldered is I will sort of just push from top and reflow to make sure that I haven't like got it at an angle. And I can even feel it that I had raised this a little bit. Now I do want to reflow this just a tiny bit. I can tell it's shifted to the right a little bit here. And so I am going to reflow one last time, shift it over a tiny bit, and then that should be good for soldering. Now again, I'm not doing any sort of like drag soldering on this, so it's really just sort of a basic like tack the individual legs. There, that one's good. It's a little tricky. The knife edge does a decent job of this in terms of letting me get in with just the very tip of the knife edge and heat leg and pad. The tricky part is sometimes the solder doesn't want to be on the very tip of my thing, and so I got to do that, and then boom, I have nicely introduced a nice short between my two legs. Again, I can try that trick where I drag it, but I've just done too much solder. I've just done too much solder here because I got these legs together like this. So what I'm going to do is I'm going to add a little flux, and I'll wick if I need to, but sometimes just the flux is enough to get them to not be shorted. Yeah, that did it. So you can see how much the flux helped here, right? I had these two legs that just like kept globbing together. Add a little flux, apply some heat, drag away from it. Totally good, right? Flux, flux, flux. If you haven't heard me say it enough, I'll say it some more. Use flux. All right, over here, we're going to get the other side done on this really quickly. Do you not solder the other side to keep it nicely in line? In this case, I could have, because I didn't really want to have to revisit that side. I held with my tweezers again to keep in place while I was doing that. You totally could do that. Is to just like, yeah, let's do the other side, then clean up. Both would be totally valid. In my case, I didn't want to come back to it because I'm worried I'm going to run out of time on stream for doing the rest of this. So I just wanted to get it cleaned up right away. So I held with tweezers and cleaned instead. All right. So we'll clean up one more here. Come on. There we go. All right. Did you like short? Yeah, exactly. Yeah, exactly right. So when I first soldered this other side over here, when I was soldering over here, I had shorted these two legs together. This big blob of solder on there, and so when you add a little flux, it changes the surface tension of the solder, and it allows it to flow more easily. And so by doing that, when I went to reflow again, it allowed the solder to really stick to the pins, which made them pull apart from each other, and they no longer shorted. Exactly right. Yep. So that was the technique there for fixing that short that I had introduced. Exactly right. Yeah. All right, so we've got our, and I don't need to check it because the pitch of this you can see is wider. I don't need to check for shorts. I can visually see that they're good. So we need to add some caps, add some resistors. I'm noticing the time. I've probably got about another 15 minutes of stream. We'll see if I can get at least the rest of the main stuff soldered down. I've been taking my time chatting. So this is where I have to actually go check and double check what I am putting where on here. And so coming up over here, I want to do all the same decoupling caps at the same time. You can see this is 100 nanofarads, and that's going to match the 100 nanofarads for the decoupling caps on my other components. So we're going to grab those first, and we're going to do C2 here, and then the other two decoupling caps on the other two ICs before we do anything else. So we're going to get C2 right here, and then we're going to get the other two. So I got to find those 100 nanofarad caps from my box o' stuff. And then we'll go. This one's done. Stack of caps. 1K. 100 nanofarads. All right, so we're doing all of the components here. I did 06, 03 for all of the other passives. And so they're fairly tiny. Not too bad, but fairly tiny. And so I need 3 of these. So I believe I'm done with those. I don't think I have any others. So this is what we're talking about in terms of the other side. This is what we're working with for our caps. So I'm going to pull these 3 out and just stash them in a corner of my little soldering mat. And then I'll grab them one at a time when I need to solder them in place. Pretty straightforward. We're going to pre-tin 1 pad. Then we're going to reflow and put them in place. Little grains of sand here. I was losing them. I wanted to make sure I had them. So, first order of business, we're going to grab one of these. This is what we're talking about, and it's a little tricky when they stick to your tweezers. But there's our cap we're going to get in place on this C2 position. So, we're going to pre-tin 1 pad. Come on, iron. There we go. I tend to pre-tin the pad that's closer to my soldering hand. I'm left-handed in this case, so I'll pre-tin the pad that's closer to where my iron is, so that I can bring in the component with my non-dominant hand into when I'm reflowing. Half the size of the solid 1, 2. It's about that, I would say. There's certainly a little fiddly, you know. If we look at, for instance, this is like a normal socket pad. It fits, inside of one of those. So it's a little small. I like tinning the pad that's closer to my soldering hand, so that I can sort of reflow and push in from the other side with my non-dominant hand running the tweezers. So I'm going to reflow, get this in there. And again, it's sometimes tricky. Sometimes they'll be sort of floating. So I like to do a second oh, wait, see, I didn't even tack down. I've got some flux residue making this a little sticky. That held decently positioned. I like to, with these again, sort of push down with my tweezers from above and reflow again to make sure that one end of these isn't floating. Yeah, see, that one was kind of floating. That's a little off, but it's good enough for what we're talking about. I'm going to tack down all of the other ends once I'm done getting these into position, only because I tend to lose these tiny components. So I kind of like getting them all into place first, and then I'll do the other ends of them. Squirrely little capacitor indeed. And so the only risk with that technique is you got to remember to get back to tacking down the other ends, or you won't do it. So tack down our second one. Grab our little grain of sand here. It's sticking to my tweezers, which have a little flux on them, which is kind of annoying. Can be handy, but is sometimes just super annoying. So we'll reflow that. Yeah, see, it was floating, so it didn't actually get it. That got it that time. So again, I will sort of push down and reflow one last time. It's down. A little off kilter, but not the end of the world. Our last one is over here. As you noted, I pre-tin this one. Do you use, you know what, I don't. I would love to try a pair. I've just never tried a pair. And so I've heard some folks love them. It would be a fun tool to try adding to my toolbox. And now this pad I pre-tinned a while ago, and I've cleaned up since then. So I'm going to add tiniest bit of flux, maybe overkill for just one cap, but it'll do. So grab our last grain of sand here. It's trying to jump away on me. There we go. All right. Forgot to dial it out. Yeah. The worst is when you like solder half of the socket legs, right, on like hot swap sockets, and they sort of kind of work, but they don't. And so like you've got like weird debouncing issues where you're like, why are my key presses not working well? And then you check and you're like, I just didn't do this other end of this hot swap. Boop, boop, boop. There's that one. Now I need to spin back again. Silly me. To get these other two here. I've got this one here I need to get the other end on. There's that looking good. This one over here will spin this way. I don't love the position on that. If I were a better man, I would fix that before I tack down the other end, but I'm not. It's going to work. If I can get my iron to be happy. That'll do. That'll do. All right, so we got our decoupling caps and all of our ICs all squared away. That's probably the cleanest of them. This one's not bad. This one's jank, but it's going to work. We got a couple other caps and resistors to do here now. Yeah, that's my only concern is like I kind of like that I am in control of when they let go or when they don't, and I can be a little careful with that. So I need a 220 PF. This is basically the capacitor that adds a baseline capacitance to a whole row or column. For the capacitive sensing, it basically is a way to mitigate one key being pressed affecting the sensing of the other keys. And so that is our 220 PF that we're going to add along our analog circuitry. I am realistically probably not going to get to finishing this tonight. So what I'd like to do is I will probably probably get like this analog circuitry stuff soldered, and then I'm going to need to step away and call it for the night. But hopefully a few folks got to enjoy some soldering work here. My single grain of 220 picofarads here. Same technique. We're going to pre-tin one pad here on C3. The only thing that is kind of annoying about this chisel, knife tip, whatever the heck it is you got to sort of like angle it just right. A normal conical tip, anywhere sort of the tip of it will have a little solder to it and it will find the pad. But here it tends to like to ride up the tip. And so does this have... Not really, it's just all white. Okay. It tends to ride up the tip a little bit, and so to pre-tin pads, you got to be sometimes a little careful. Now that is a gross joint. So here's a perfect example of a gross joint, right? Like you can see there's this little wispy coming off of it because I left my iron a little too long and all the rosin core had pulled out, and this IPA that's on here is probably mucking with it. But like it's sharp. It's just like it's poking my finger sharp. And so as much as that joint may work, long term, it's really not a great joint. And so I don't want that to stay. So we'll add a little flux, and we're going to reflow it, and we'll compare how this looks once I get a little flux and a reflow on it. It's spiky right now. Your joints should never be spiky. Just a few around the op amp. Yeah, so here's what we've got left. We've got, the op amp has this extra cap. We've got three more resistors, which are around like biasing some things and a few other things, right? And then there are individual pull down resistors on the columns. Yeah, no stabsies. But there's no switches to solder. There's no diodes to solder for like a matrix. And so we're going to actually reflow and push this down a little bit. Come on, little guy. Yes, that's looking better. So we're going to shift it a tiny bit. But see that nice round joint? So much better than that stabby grossness that was there before we started fixing it. All right, we're going to spin this around. We'll get that other side. It's like off a little bit. You can see it's just a little to the side, but it's not so far to the side that I won't be able to get to that pad and get it just tacked down with a little bit of solder. Yeah, totally fine. All right, so we're going to get these last few resistors in place. I'm not going to get to the controller area. If I don't get some dinner started here, it's going to be problematic here in just a little bit. And so we can see I got a 1K resistor. I actually am going to do that one. I'm trying to remember. Are these 1K or 100K? Those are 100K, yes. Okay, so we've got our 1K resistor here at R8. We've got a 1 million resistor here. And we've got a 100K. The 100K I do at the end because I've got a bunch of other 100K resistors along the columns. No, they aren't. They are not attached. So the thing that attaches the electrocapacitive housings, domes, and springs is the plate assembly being screwed to the PCB. So they are not physically attached to the PCB at all. They float on top of it. Yes. And so if we take a look here, if you look at the pads here, here's an EC pad. And so a spring is going to sit on top of this pad. And there's two sides here with a ground between the two. Okay. And so when that spring is standing tall over top of this, there's a certain amount of coupling basically between the pad on the left and the pad on the right. When you, I don't know, theme. And so when that spring is fully pushed down, it is actually coupling these two pads to each other more tightly. And so when one side of the pad, when one side of this pad gets a voltage spike, spiking it, because there's more coupling between the two, there's a parasitic spike of voltage, tiny voltage, on the other pad on the other side. That other pad is this thing that will be, by thanks of like the analog muxes, depending on which one we're trying to sense, we will have that other pad connected by way of our analog muxes to our op amp, which is going to amplify that little voltage spike to a higher voltage that can actually be read by our analog pin on our controller. Okay, so that's the sensing technique for Topre. So you strobe one side, boop. Depending on how far the spring is pushed down, that parasitic voltage will spike on the other pad, which is then going to get picked up after it's amplified by your op amp on the ADC pin on your controller. Yeah, so there's nothing physically connecting that whole, like the spring and dome. The spring sits inside of the dome sits inside of the housing, and that whole thing, the plate structure sort of pushes it down onto the PCB. Yep, that's the deal there. So no, we don't need to solder anything in terms of like switches or whatever to this. Where are we? Over here. R8 was a 1K resistor. Let's see if we can find those. 1K resistor. I can look later, Syxos. I don't know. Is that how you pronounce your name, your handle? Is there a better way to do that? Or am I butchering it? All right. So we've got a single 1K resistor. We're going to put an R8. We got to find a 1 million resistor. We're going to put an R16. Try not to drop this tiny thing. Come on out. Well, it dropped somewhere. Find the little resistor. I might need to grab another one of those. I did not see where that fell. Ooh, a tiny resistor hunt. Did it stick to my PCB anywhere? I'm going to find that one on the carpet later. Did it stick to my flux anywhere? Yeah, the only problem with these 0603s is these tiny suckers, if you lose track of them, they're gone. Oh, I see it. I see it. It had flipped over. So the surface of this little USB microscope is white. And when these little tiny resistors flip over, the body is white on the back of them. And so if they flip onto their, where do we go? If they flip onto their backside, they're white and they blend into the white surface of this really well. So I always have to be careful. If I lose one of these, it's like it'll really blend in. Really blend in. So we're going to pre-tin here. Flip this over, although it doesn't matter. The particular person in me wants this to be oriented the right way. Flip it over. Get it off my tweezers. That's just great. We'll tack that down. Done. While we're here, we're going to pre-tin that pad. I'll find my 1 million. So I tweaked the design a little bit on this. Spring-loaded pins. Previously, I had decided to use a like a jumper for the enable pin for the like optional power pin for my op amp. But I realized what I probably just wanted to do was use a pull-up resistor to default it. And then it would just be the right thing. And then if you chose to build this the wireless version, where you might be toggling that pin, there'll be like minimal drain through my pull-up, but I won't risk having a hot path if you had done the jumper and then started setting the control pin on the controller low. And so that was my tweak on the design here. Okay, we've got our, yet again, upside down resistor there. Fix it. There we go. Spin this a little bit to make it a little bit easier to work on. Again, I'm going to do the same trick to make sure that one end isn't floating. Totally good. Spin this around and tack down the other side. Clean looking joint. All right, next up, we got a bunch of 100K resistors. Do you have any ventilation set up? No, I'm chaotic evil. I blow sometimes. I'm bad about that. I probably should be better about it, but I'm not. Don't do what I do. I guess that's the lesson for several of the things we've done here today. All right, we've got a bunch of 100K resistors we need. So in this case, we need 13 of these. We've got one for each column. And then we've got this one by our op amp. So 2, 4, 6, 8, 10, 12, 13. All right, it's 5:30. I'm going to do these 100K resistors, and then I'm going to have to call it for the night. I got to get some dinner cooking. Kids are going to get back. It's going to get loud in the background here pretty soon. So we'll do these quickly, and then we'll call it. Any last Topre questions? Now, thankfully, my understanding is that lead does not aerosolize, that you are not getting lead into your bodies. You certainly could by contact, by way of all the stuff I've been touching. So I'm going to wash my hands very well here coming up. But that lead itself does not aerosolize. It can't go in the air. That what you're probably getting is a bunch of gross flux fumes that probably are not good for you. But you're not going to be getting any lead in by way of the fumes. The lead's going to be coming in when I don't wash my hands after touching all this stuff, and then grabbing that apple slice and eating it, right? That sort of transfer is where you're getting your lead from your leaded solder, is my understanding of things. If somebody wants to correct me on that, I am open to be corrected. But it's mostly the solder, yeah, pretty much. And so that's my understanding here, is that the fumes, plenty of not great stuff, not the lead. You're going to get the lead by way of touching this and not washing your hands, or like reusing tools for other things, etc. So we've got our resistor here. We're going to fix the orientation of this a little bit. That's fine. That was actually not great joint. There we go. Now the R9 here is actually a do not place. It's not actually needed right now. It's for, in theory, tuning the analog circuitry here, but I don't need to. It's been pretty stable so far, so I'm leaving that one unpopulated right now. And so here's what we've got. On each of these columns, there's an extra pull down resistor. And so we are going to get all of those done. So really quickly, I'm going to pre-tin all of the one sides and all of these. Then I'm going to get all of the resistors in place, and then I'll do the other side. I like pre-tinning not the ground side, because I find the ground side harder and more annoying to reflow when I'm placing my resistors. So I tend to do the ones that are on the actual lines, not the ends that are the ground end. All right, we're going to work our way backwards. Yeah, exactly. The ground side, because there's a ground plane here. Look at this awesome bit of fuzz I picked up on my tweezers. Yeah, because the ground side, you can see there's these spokes. Still have fuzz on my tweezers. But nonetheless, there's still way more of a connection between that pad and my giant, massive, like thermal sink that is the ground plane. And so if I, oh, and you can even see, look at this. Again, a little spiky guy here. I'm going to add a little flux. If I have to reflow that other side, then it's just going to take me a little bit longer to heat it a second time for connecting my resistor. So I would much rather do that once when I'm soldering it in place than having to do it twice, one when I tin the pad and the other time when I'm soldering the other side. So that's my preference, is to not have to deal with heating up that thermal mass of the ground pin twice. Yep. Come on off. Come on off my tweezer. Naughty resistor. It's really stuck on there. Of course, I've knocked it, flipped it over. Play a little tiddlywinks here. There we go. All right, I got to go in a minute. So, who's got other Topre questions? No takers. I've got, I think, flux residue on my tweezers, so they keep sticking to my little resistors. Oh, look at this. Again, gross spiky. You can make these connections thinner, which helps, but I really hate soldering gross. Yeah. It's just that little extra bit of something, right? So if I don't have to do it twice, I'm happy. That's a cleaner pad. There we go. Come on off my tweezers. My tweezers have gotten so gummy. It's all right. It gave me a chance to soak this in a little flux, which it can't hurt. One more on this side. That'll work there. All right, so we're going to do the same thing. We're going to pre-tin our pads on the other side. And then what I'm going to have to do, because I'm really over time, next soldering session, I will go through and I will, yeah, okay, I'm actually going to spin this around to solder these. I will actually go through and solder the other sides of them, or I'll forget, and it'll be fun diagnosing what's going on with the connections with my analog sensing. We'll pre-tin all the pads, get these down. And we'll see if I have the if I'm able to not do this on stream, if I'm too impatient and I just do it next time I have a free moment to finish assembly on these prototypes. Come on off my tweezers, you silly thing. My tweezers are so gummed up at this point, I need to clean them off. There we go. Ooh, a little bit of cotton fuzz from my Q-tip cleaning there. Great. All right, so what do folks think of build streams versus my coding streams? Is this a good use of your time? Come on, little. Yeah. See, I'm rushing. Normally I'd be like, add more flux. But because I wanted to get this done. Yeah, well, the key thing will be can I get the dinner done in time before the girls get too hungry? Then we've got a problem. Oh, don't stand up. Silly resistor. Ooh, I'm pretty sure I just shot that one into oblivion. Oh, that resistor's gone. Yeah, I just yeeted that one to who knows where. Try this again. Add a little flux. Don't be lazy. Just a touch. God, those are some gross tweezers, everybody. Major fuzz from the cotton from my Q-tips I was using for cleaning. All right, 3 more of these to get tacked down. I'll just pre-flux them all since I know I'm headed there. Yeah, the one that I bounced in the middle of nowhere. Did I find it? No, fuzz. Yeah, that one's done. I gotta grab one more. Then we're gonna call it for the night. Go get the rice and beans cooking. Okay. Do. All right, so the things that are going to be left to work on this are going to be the controller. The main thing is the controller, and then the actual full assembly. But in terms of the actual soldering, there's solder nuts to do, which are always interesting because they take a lot of just heat from your iron. And then there's all the controller area, the sockets, the pogo pins that I'm using for the the battery and the extra pad. And then the controller itself, because I have these low profile sockets I'm using, I think the pins that are in my controllers already are going to be too long. I'm going to need to redo them. Okay. All of my tiny resistors are tacked down at least. Oh yeah, they're gone. They're totally gone for sure. All right, so there's the the meat and potatoes was really all the work here in the muxes, the op amp. We're gonna give a quick scrub with our IPA while I'm here, while I'm thinking of it, just to clean it up one more time. Just because I never did that over here, you can see massive amounts of just gross flux residue everywhere from doing this. This is looking pretty good, this area. I was rushing a little bit. You can see it in like the C2 is not lined up perfectly and things like that, but it's looking pretty good in terms of the soldering. The drag soldering, the first one was a massive disaster, and then from there we learned not too much, never too much when you're doing the, and it looks like it's an interesting, oh, I just had liquid in there from my IPA wash. So yeah, that's the bulk of the analog stuff done. All the interesting Topre bits are on and soldered. Now it's really just all the other stuff. So we're going to solder some interesting pogo pins in these. We're going to get the sockets on, and then our solder nuts here, which are the things that are going to hold the case to the PCB. So that'll do for the night. Thanks everybody for joining me. We made some fun progress. Some fun questions. Thank you everybody for the questions. I can't promise that I won't get too tempted and I won't do the rest of this build not on stream. I will try and be diligent and wait, but no promises. So next step, since I've been touching a bunch of solder stuff with lead, as I noted earlier, I'm gonna go wash my hands when I'm done cleaning up. So thanks everybody for joining. Thanks for the questions. Thanks for hanging out. I'll hopefully put up some pics once this thing's built and working. Have a good night, everybody.